Good morning, everyone. Hope you are doing well. Today we are going to start new lesson, database development. These are the learning outcomes. So we need to understand the basics of information and data and the need for a database. Then understand the concept of relational databases. Understand the main component of a database. Then how to design a database, how to logically design a database using conceptual schema. So based on that, how can we physically implement that, right? So how can we convert that ER diagrams to a actual database? Let's learn about the normalization as well, right? Okay. So first we'll discuss about what is information and what is data. So can tell me what is data? Venazi, what is data?
Sir, it's information.
Not information, but the data are raw facts that does not have a meaning or context, right? This data is raw facts. So to data to be meaningful, we need to process them. After processing the data, they become information which we can use to make informed decisions. Data are raw, unprocessed facts that need context to become useful, that need context of processing to become useful. Then we can get information. Based on this information, we can make decision. As an example, what if I tell you a number, like let's say 85. This is a number. So what can you tell, what can you tell by looking at this? It's just a number, right? It's just a fact. So we can't tell based on this fact. What if I tell you this is a exam mark of a student? If I know that, I can make decisions. That means he will get an A pass for this subject. Data is the most important asset in the modern digital world. Can you see the screen, Binazir?
Yes, sir, I can.
So, what is data? What is data? Data are raw facts that does not have a context. Then what is information? After processing, analyzing, and giving a context to that data, they will become information, right? Which we can use to make informed decisions. And data has a life cycle. So we generate data, then it's like humans, right? As humans, we come to this world as a small baby, then we grow up, we go to school, we go to the university, then we go to a job, then we will have a family, then eventually we will die. Data is also the same. So data is a generation, then the analyzing, then based on that analyzing, we make decisions, and finally we will archive them or delete the data. So we have the data generation, data storage, cleaning, integration, analysis, visualization, reporting, decision making, archival, or deletion. So this is the data life cycle. So throughout this data life cycle, we need to maintain data integrity. Data integrity. Data integrity. means data need to be accurate, consistent, timely, and reliable. If the data is accurate, consistent, reliable, timely only, we can make decisions. So I was discussing what is a database. A database is a collection of data maintained structured. It's a way of maintaining data structurally. So why we need to maintain data structurally is because it allows us to efficiently access, manage, and update data. But we can manage data either using a traditional methods or with the computing technology. Right? So in the early days, people used file-based systems to manage data. So what are the problems with this traditional method? It's time consuming, right? So finding and updating records will take a lot of time. Then human errors can occur, right? Prompt to human errors. Most of the times, humans are the ones who update these records, right? So more prompt to human errors. Then security, security is lacking, right? Like lack of security and data consistency. Is it consistent, right? So there's a branch in Candy and there's a branch in Kalam, right? So whenever some record get updated in Candy, will it be updated in the same time in Colombo as well? No, right? Because they have two separate file-based databases. It's difficult to analyze this data as well, right? It's difficult to analyze this data. So when then the computer technology developed, right? So people will start thinking, okay, can we use computers uh, to store our data, or can we use computers as databases? If we can use a computer, so it will be less time consuming, duplication, or data inconsistency, right? So uh, even though there is two branches, let's say Candy and Colombo, both use the same database. So whenever something get updated from Candy, automatically the updated data will be available in Colombo as well. Right? Then the security wise, security can be, we can implement security measures. So security is higher. So people were thinking, can we use computer technology to implement databases? How can we use computers to store our data? There are uh, different type of data models. Like so, when people start thinking, how can we implement the computers to store data, so create a database, they suggested different database models, different database models. First one is flat file model. First one is flat file model, right? So in the first flat file model, we store data in a single table or a single spreadsheet. Right? All the data will be stored in a one single spreadsheet. As an example, think of this example. Someone is working at a private company as a software developer. He lives at number 5 Main Street, Colombo. Someone has been working at the company for 3 years and he holds a bachelor's degree in information technology. So how can we structure this data? So we can structure this data into a table. In the table, we have these attributes and the value. Let's say someone's employee ID is 1 and the name is someone, job title is a software developer, address Number 5, Main Street, Colombo. His experience, 3 years. Qualification, bachelor's degree in information technology. Right? So rather than keeping the data like this, after structuring it in a table format, the data is more structured, right? So now when we want to add another employee, we can easily uh, uh, insert a new record to this table. So in a flat file, we store data in a single table or a file. All data is stored in rows and columns without any relationship between different data types. So we are not considering about any relationships. We are just putting the data into a one single table. As an example, here, if you want to add another item 014, let's say item is cola, price is 150, unit selling price, let's say 170, quantity sales within months, let's say 2000 liters, right? So we are not considering about a relationship. We keep all the data in one single table or one single record. What are the advantages of this model? So it was simple and easy to simple to create and use. It was simple to create and use, and it was efficient for storing small volumes of data, and it had a low overhead. So we don't have to think much. We just putting data into a one single spreadsheet, right? So as an example is a CSV file or a Excel file. You can think about an Excel file. So what are the limitations of this model? So there is no relationships between this data. So which can lead to the same data can get stored repeatedly. Let's say as an example, we have another item as milk. Its unit buying price, let's say 140, unit selling price, let's say it's 150. So even though this data is the same, we have to add another row here. So these data will get repeated. Then when the data set gets larger, it will be harder to retrieve data. It will be harder to retrieve, update, and delete data. Because of these limitations, they came up with this model, hierarchical model. Right? They came up with hierarchical model. In the hierarchical model, we store data, we organize data in a tree-like structure. We organize data in a tree-like structure. Tree-like structure where we have the parent-child relationship. Parent-child relationship. In a hierarchical model, it has a tree-like structure with parent-child relationship, right? So in the top, we have the root, then we have the first level childs. Then from this first level childs, we have the second level childs, right? And you can see each child has only one parent. Each child has only one parent, but one parent has many children. So that means what? One parent can have many children, but one children can have only one parent. So model only supported one-to-many relationships. Right? Therefore, to access a record in let's say in the second level, so to access this record, I need to go systematically down from the base class. Right? First, I need to go to the base, then to this first level child, then to this second level child. Right? So I can't access directly this data. Understood? I can't directly access data in this child. So as an example, uh, this is a hierarchical model of a college database. First, we have the college, then each college has different departments and different buildings, and each department will have students and a teacher, students and teachers, and each student will have a student ID and the assigned department. Right, this department is studying, and each department will have a teacher, and teacher will have an teacher ID, and he will be conducting labs. Right? So let's say I want to access this student ID. So I want to get this student ID. So first I need to give the college, then department, then student. From that I can get the student ID. So this database model had the advantages of we were able to compare to flat file system, we were able to store a large amount of data here, and it was efficient for storing data with clear one-to-many relationships. So compared to flat files, it was uh, efficient in storing large amount of data, specifically a data with clear one-to-many relationships. But the limitations were this had a complex structure. The database structure was complex. So, right? So making any changes to this structure was very difficult. Right? So doing a change to this structure was difficult. And specifically, many-to-many relationships was not supported. Let's say here, can we combine this teacher and the student? Right? Let's say most of the times a teacher will teach many students, and a student will get teach by many teachers. Right? So there were no way organizing that using this hierarchical model. It only supported one-to-many relationships, right? And so since we to get the data from a child, we had to go systematically down. So it was difficult to recognize and access data from different branches. Right? It was difficult to access data. Right? So in hierarchy in flat file, we store data in a one single table or a spreadsheet. So then in hierarchical model, the database is organized like a tree, like with parent-child relationships. So because of that, we can represent only one-to-many relationships. Right? Okay. So because these limitations, they introduce a new database model, a network model. And the database structure is like a graph, right? Not a hierarchical model. It's a graph, like each parent has many childs, and each child has many parents. Store is connected with clerks and customers, and clerk is connected with transactions and store likewise. So it has a graph-like structure and support many relationships, right? So what are the advantages of this work? We can use this to store large amount of data, and it supported many to many relationships. It supported many to many relationships, and it was, compared to hierarchical model, it was more flexible. Right? It was more flexible, so we don't had to go systematically down to get data, right? So more flexible than that, and it had an improved data access. However, the limitations were, even though it was more flexible, but the structure, the database structure was very complex. The database structure was very complex. So therefore, it was difficult to design and maintain. The personas with good understanding of this database engineering needed to uh, maintain these databases. Users were required to know the physical representation of the database model. So to get the data, the users were required to have a good understanding about this database architecture. Then, because of these limitations, they introduced a new model as relational database model. This is the database model we are using currently. Right? The relational database model is the most widely using database model. So it was introduced by this person, EF4, in 1970. EF4 introduced this relational database concept. So here we organize data in tables, but we organize data in tables, and these tables are connected with primary keys and foreign keys. These tables are interconnected with primary keys and foreign keys. The core idea behind this relational model is to define relationships between different tables using keys. So the basic idea was, we are not keeping a hierarchy or a graph. We we keep data in a table, and from within this table, we identify a primary key attribute, right? That means a unique value for that table, for that particular table. Let's say we have a student will have a number, name, age, then a grade, likewise some attribute, right? From that student table, we identify a unique attribute. Let's say student ID. Student ID will be unique for that particular student, right? For each, right? Let's say there is 100 students, there will be 100 different IDs to uniquely identify each student, right? So from each table, we identify a unique attribute. Then using these unique attributes, we call that the primary key attribute. Using the primary key attributes, we try to create relationships between different tables. Right? So the core idea of relational model is to define relationships between different tables using keys. So every table typically has a primary key, which is a uniquely identify each row. So relationships between tables are established through foreign keys. That means one table's primary key, we put it into a related table as a new field. We call that a foreign key, right? So using that primary key, foreign key concept, we can define relationships between tables. So therefore, we were able to represent one to many and many to many relationships. So in the hierarchical model, we were only able to represent one to many relationships, and the graph network model, we were able to represent many to many relationships and one to many relationships, but the database structure was rigid and complex. So here we can represent one to many relationships and many to many relationships, and they develop database management systems and the programming languages called SQL to retrieve data or to manipulate data in these relational databases. Because of that, we were able to efficiently retrieve data in a less time and update data. Examples are MySQL, PostgreSQL, Microsoft SQL Server. Those are examples of relational databases. However, it will have some limitations. So whenever the data set, our database or the schema getting larger, this data retrieval can become slow. The system can get slow, right? Can become slow with large data set. Sometimes, since there are many number of tables, we have to combine tables to get some value, right? Let's say we have a different table like student and the teacher. So we want to get who is the teacher teaching this student. So we have to take the student from one table and the teacher from another table. So we need to combine these two tables, right? So imagine there is 100,000 tables, right? We have to use complex joins to retrieve data, right? So it can get complex, and the main thing is we were not able to store unstructured data in this database. So if we can't find the relationship between data, so we are not able to store that data in a relational database. Structured data means structured data is organized and stored data in predefined formats such as tables with rows and columns. Organized and stored in predefined formats such as tables with rows and columns. It has a clear structure, so therefore it's easy to store, search, and analyze. So example is data in Excel sheet, SQL databases. Okay, and unstructured data is the data that are not organized, and the data that we can't organize in a structured way, like in a table, right? So it is difficult to search, process, and analyze these data directly. So again, in a relational database, we have tables. Each table will have a primary key attribute, and this relationship between tables is created with primary keys and foreign keys. And because of these limitations of the relational database, the new concept like object relational model was developed, right? So there are the relational database concept and the object-oriented programming concepts is combined. So it has combined features of relational databases and object-oriented programming. So it supports like classes, inheritance, and complex data types. So as an example, look at this example: object relational databases. Right? In object-oriented programming, what are the object-oriented concepts? Inheritance, polymorphism, abstraction, encapsulation. Right? So here you can see I am creating a student. I'm creating a student. Student has a ID, which is his primary key. Name, name is a character, and contact address. You can see contact address is will be having a street, a city, and the postal code. Here you can see I am using inheritance. It's like I have another object as address, which has the street, city, postal code. So I can define contact address from the type of address from address type. So which will be having street, city, postal code. You can see in the code we have the object-oriented principles. So the object relational model supports the concept of relational databases and the object-oriented concept. It still have all the advantages of relational databases. With that, it is able to handle complex applications. It's able to handle complex applications, complex applications, and support complex data types and relationships. Most importantly, offer both relational and object-oriented advantages. Examples are PostgreSQL with object relational features and Oracle databases. However, it still have limitations. So it's complex. It's more complex to design than a relational database relational model, and it has a performance overhead. So that means compared to relational model, we need to have a extra processing time, memory usage, or system resources required compared to pure relational systems. What you need to understand is the most commonly using and database model is relational model. So from this onwards, we are going to discuss more about this relational databases. So we are going to learn about relational databases. Okay. Here we have a comparison of these database models. So if we consider about the structure, this flat file system have a single table or it's a single table or a single file. Then a hierarchical model, we had a tree-like structure, and in the network model, we had a graph-like structure. In the relational model, we had the table-based structure, and table had primary keys and primary key attributes. Using primary keys and foreign keys, we define relationships between these tables. An object relational model with the object-oriented principles. It had oriented features. Were we able to define relationship in a flat file model? No, we were not able to imply hierarchical model. Only one-to-many relationships were supported. Right? Network model, many-to-many were supported, and Here, one-to-many and many-to-many both supported. Relational model and the object relation model, one-to-many and many-to-many were supported. From the use, flat file model is obvious, very simple, so you can easy to use. Hierarchical model, on the other hand, very complex structure. It has a complex structure and it was very hard to modify and to do changes. It was very hard to modify. Network model even complex than the hierarchical model. It was even complex than the hierarchical model. So to use that data model, we need to have a good understanding about the data structure, right? So in the relational model, however, was easy to use because it had the programming languages like SQL. So using SQL, we were able to easily retrieve data from relational databases. Okay. On the other hand, object relational model is complex than the relational model, but it's powerful. Flexibility, flat file model was not flexible, right? So we put everything into one table or one spreadsheet. So not suitable for handling complex data. And the hierarchical model, we had a rigid structure and doing changes is difficult because it has a rigid tree-like structure. So doing changes is difficult. Network model flexible than the hierarchy model, right? Supported main-to-main relationship, but still it was difficult. Then relational database, it's easier to it's easier, it's flexible, right? We can easily add a new table, uh, define relationships, right? Then object relation model is highly flexible because it supports object-oriented concepts as well. Query language support, flat file, there was no query language support. Go systematically down from the base to the child node to retrieve data. So it's procedural. Network model is also procedural. And relational model supported SQL. Relation model and the object relation model support SQL language, right? The flat file, right? Then these were developed like early stages of databases, hierarchical and network model. Then the relational model is the most widely using database model. It's flexible. It's suitable for business applications, web applications, likewise. So when the object relational model came, so when there is a need for developing an advanced database system, we can go for object relational model. So examples are flat file model. Example is Excel spreadsheet. For hierarchical model, we can consider file directory system, then networks telecom system, then SQL relation model, like the everyday database models like code management system, uh, like inventory management systems, likewise. Compared to this, so the more complex applications like multimedia applications, CAD systems, these will be requiring more complex database structures like object relational model, right? So we are going to discuss mainly about this relational model. So if you understood what I discussed, can you tell me the answers for these questions? So shall we discuss this question? Right. So, Binazir, can you tell me the answer for this question? Which of the following database type is widely used in computer applications? Flat file, hierarchical, network, relational, object oriented.
So network.
Network? No, no, not the network. It's relational model, right? Relational model is the most widely using database type in the computer applications today. Then tell me the answer for this as well. Consider the following statements about computerized databases. So we discussed there before the development of computerized databases, we were using file-based systems, traditional file-based systems, right? So we keep data in files, right? Then organize data into these files, and we have different this manual system, right? So compared to those, uh, uh, which of the following statements are uh, correct about computerized database? Need more human resource to manage computerized database than a manual system. Do we need more human resources to manage the computerized databases than a manual system?
No.
Right? Then retrieval of data is efficient than a manual system. Is it correct? Compared to a manual system, can we retrieve data faster using a computerized database?
Yeah, second one is correct.
Second one is correct. Then no data duplication. Can we reduce data duplication using a computerized database?
Yes, we can.
Then do we need more space to store data than a manual system?
No.
In a manual system, we have many racks that then store these files, so it will take a lot of space. Yes. And so, like, imagine a library. In a library, we have it's taking so much space, right? So we can organize all that book into a computer in our laptop, right? We can store all that books PDF format in a laptop, right? So we don't need that space, right? So compare, we don't need more spaces to store the data than the manual system. So what is the answer? B and C. Consider following the statements about relational databases. A table is considered as an object, a column of that table. Is that correct? Is that correct, Benazir?
Yes, sir.
In a relational table,
Correct.
yes, we have tables, and each column will represent an attribute, right? It's a student table. Student will have an ID, name, age, and so a column in the data table is called a field and attribute of that table. That is correct. A row of the data in the table is called a record. Row means this. Rows. A row will represent a record. That's correct, right? So
Yeah.
in the student table, I can put Nazir, then a new student, likewise. So each column will represent an attribute and each row will represent B and C. B and C. So we are not considering the table as an object. Which of the following is correct with respect to the term domain in a relational database? So what do we mean by domain? Domain means So we have a table. I have a table like this. Let's say this is a student table. Student, student table, and the student will have an age, and a student will have an age. So can I put a value like 10 to this column? Can I put 10 to this column? Can somebody's age can be 10? Yes, right? I
It's a
can put
number,
10
no?
here.
Yeah.
Then can I put Benazir here? Benazir. Can I
No.
put your age as Benazir? No, no. Then can I put minus 25 here? Can I put minus 25 here?
No.
No, right? The person's age can be minus. No, right? So it's need to be start from 0, 2, 3, 4, 5 like this. Can I put 250 here?
No.
250? Can I put here? No, right? The person will not live that much longer.
Possible.
So
Yeah.
the domain means the set of value take or that uh, attribute can take that we call as the domain. So what's the answer there? It's the set of all possible values of an attribute. Domain means the set of all possible values of an attribute. Right? Right. Now, so Bhudev, so now we have discussed about different data models. What are the models we had? Flat file model, hierarchical model,
Network.
network,
Relational.
relation,
Object.
and the object relational model. Right? Then we are going to discuss more about this relational database model. In a relational model, we have tables, and each table has uh, each table has attributes. The columns represent attributes, and rows represent different records. And there is a primary key attribute which is the unique identifier records, right? Can I change this person's? This is the primary key. Roll number is the primary key attribute. So can I change this race primary key as 1? So roll number as 1.
No, we can't.
No, we can't, because then there will be duplicate value.
Yeah.
Duplicate value, right? So can the primary key get duplicate? Can the primary key value have duplicates? No, because then how can I uniquely identify this Ramesh and Suresh? Right? So I can't change his role. So primary key attribute is that a unique identifier. So using that attribute, I can uniquely identify the particular record. Right? Okay. So each table has a primary key, and the relationship between these tables will be defined using these primary keys and the foreign keys. And the main components of relational models are tables. Tables. Data is organized into tables, or we call them relations. Relations. Tables, or we call them relations, which will have rows and columns. Each row represents a record, and each column represents a particular attribute. Right? And each table will represent an entity, a real world object. So that we need to keep data about. Okay. Then like student, teacher, right? Then we have attributes. each entity will have attributes. That attributes will be represented by columns, right? That's entity student, student with the ID, name, like question. So define the attributes, define the structure of the table. So it will represent property or characteristic of the entity, like student ID, name, age. The degree means the degree of the relation means number of columns the table or the relation has. So the degree is 1, 2, 3, 4, 5. 5 number of columns this table has. Then we have rows, or we call them tuples. We call them rows or tuples, which will represent a single record. Which will represent a single record. Then the primary key is the unique identifier for each record. Unique identifier for each record, which will ensure that there is no duplicate rows. There is no duplicate rows. So using foreign keys or an attribute of one table that refers to primary key in another table. If there is two tables like student and the department, so in the student will be having a department. So if I write in the student table, there will be another column as department ID, ID. So there I put the department's primary key into the student table. So that we call as the foreign key. In the student table, there will be a foreign key as a department ID, which is the primary key of the department table. So then using that foreign key, I can combine these two tables. That's the idea. Then the domain is the set of values that an attribute can take, right? Then you need to understand this. The database is a part of the IT system, right? Database is part of the IT system. So what is a system? What is a system we discuss in our system design? We discuss what is a system. First, or more units working together to achieve a common purpose. You can define a system as two or more units working together to achieve a common purpose. So a system in the IT system is always the same. It's a set of units like hardware, software, networks, and processors working together to collect, process, store, and distribute information to support decision making. Right? In this IT system, like network, like software, databases is also part of this IT system. Database is also part of this system. Right? Database is also part of this IT system. So, when we are designing or developing a database means what? We are developing a database or designing a database means what actually? It means, we, according to the requirements, we need to identify, okay, these are the tables that I should have. These are the attributes of these are the entities I should have in my table. These are the attributes it should have. These are the relationships it should have. Likewise, we need to properly design our database based on the requirements, right? So it's like how we design a system, right? like that, we need to design our database, right? So these are we call as business rules. Business rules. We design or develop a database for a particular system. It's a part of the system. So it will be having a requirements, right? So based on these requirements, we should design the database. So before developing the database, first we need to identify this requirement and design it first, right? It's like building a house. It's like building a house. So when we want to develop a house, straight away we are not starting the development, right? First we create the plan based on the requirement. So here the plan we develop, we call it as the ER diagram, right? The database ER diagram. ER diagram is a graphical representation of an entities and their relationships to each other in a database. ER diagram is a graphical representation of an entities and their relationships to each other in a database. ER model is based on three concepts: entities, attributes, and relationships. ER model is based on three concepts: entities, attributes, and relationships. The three building blocks of data models are entities, attributes, and relationships. What do we mean by an entity? What is an entity? An entity is a real world object that is relevant and important to the system being designed. It's a real world object. It's a thing that we need to keep data about, right? In our database, it's a thing that we need to keep data about. A real world object that is relevant and important to the system being studied. Right? As an example, in an employee management system, let's say we have an employee management system for a company. So employee will be an entity. So we need to keep data about the employees. Right? If it's a school management system, what do we need to keep about? We need to keep data about teachers. An entity, put a star mark and write, an entity should be important to the system being designed. Something that is important to the system being designed. So as an example, if I ask you, so if I'm developing a system for a student management system. So here, do I need to keep data about students? Do I need to keep data about students? Yes, I do, right? So it's an important thing for the student management system. Then, do I need to keep data about the teachers? Yes, I do, right? Yes, I do, right? Then, do I need to keep data about the parents? Maybe yes, right? Do I need to keep data about the parents? Yes. Do I need to keep data about the... So it's not important to the student management system. And occurrences that in the student management system, there should be many students. Right? So if there is no many students, what's the purpose of creating a student management system? So likewise, so it should have multiple occurrences. There should have multiple occurrences, and each instance must be uniquely identifiable. So we should be able to define a primary key attribute for that particular entity, right? So, and in an ER diagram, we denote an entity using a rectangle. We denote an denote an entity with this symbol, a rectangle. Okay, right. So if you understood that, can you tell me the answer for this? So can you find the entities for this business rule or the system description? The Johannesburg Country Basketball Conference is an amateur basketball association. Each city in the country has one team that represents it. Each team has a maximum of 12 players and a minimum of 9 players. Each team also has up to 3 coaches, offensive, defensive, and PT coaches. Each team plays 2 games, homes and visitor, against each of the other teams during the season. So, what are the entities you can find? The Johannesburg Country Basketball Conference is an amateur basketball association. Each city, so there are many cities. Each city in the country has one team that represents it, and each team has a minimum of 12 players. There are many players, so we can consider player, and minimum of 9 players, 12 players, and a minimum of 9 players. Each team also has up to 3 coaches. There are coaches, so coach is another entity. Each team plays 2 games, right? Then game is another entity, a real world thing that we need to keep data about. So in our database, there will be entities like this city, then the team, and player, and coach, and game. So these will be our entities. Then each entity will have attributes. Attributes are property or characteristics of an entity, right? So these attributes can be divided into 5. First is simple attributes. Right? Simple attributes, or we call the normal attributes. Salary, something like salary. First name, those things can't be divided further. Normal attribute. So entity, say person, he will have a normal attribute like this. Normal attributes is denote like this. Salary. Then we have composite attributes. Composite attributes, the attributes that can be divided into subparts. Example is the name. Right? Most of the times, the name is a combination of the first name and the last name. Right? My name is Chamindu Kasun. So my first name is Chamindu, second name is Kasun. Right? So we represent the composite attribute like this. We have the name. It is a composite attribute. So we represent the composite values as attributes of that attribute, that particular attribute. So name is consist of first name and the last name. Right? Understood? Right. Then we have the derived attributes. So derived attributes means we derive that attribute from another attribute. So So imagine in my database, I want to keep the student, his name and some other attributes and his age, Right. So, let's say I have a student, let's say Nimal. His age is, let's say 12. I am putting this as 20. Okay. Then Kamal is. So, I'm creating this database today. I'm creating this database today. I'm creating this database in 2025. So, and I will keep that data and somebody else will try to use this data in 2027. So at that time, is this data record is correct? No, right? Because this age 20 was in 2025. So now it's like it has to be 22. Kamal's age has to be 27. Right? So, like in this case, what should I keep? Age? Is it correct? Keep the age? No, right? I should have keep not the age, not the age. I should have keep his date of birth. Then, no matter what, even if I check it this in 2050, still I can find Nimal's age, right? I want age, but what I'm keeping in the database is the date of birth, right? So those attributes are called derived attribute. They are not stored directly. We are deriving it from other attribute. Example, age. What we want is age, but in our table, we are not keeping age, we are keeping date of birth. So we are deriving date of birth from, we are deriving age from this date of birth. So therefore, our database is consistent and timely. The multi-value attribute, So we denote the derived attribute using dotted lines. Age, dotted lines, and the attribute we can represent like a normal attribute. Then we have multi-value attributes. Take a look at this example. We have an employee. Employee is the entity. Employee entity. He will have a name. Name is a composite attribute. So it's a combination of first name and second name. And he has the primary key attribute as employee ID. Then he has a derived attribute from as age from date of birth. And let's say let's say he has a telephone number, which is a multi-valued attribute, and salary, something like salary, it's a normal attribute. Okay, right. Then we discussed that in ER model, the concept is based on three things: entities, attributes, and relationships. So now we will discuss about these relationships. So we call cardinality. We call that cardinality. Cardinality defines the number of instances of one entity associated with instances of another entity in a relationship. Number of instances of one entity associated with instance of another entity. So we have three relationship types as one to one, one to many, and many to many. Okay. So one to one means one instance of A is related to only one instance of B, and one instance of B is related to only one instance of entity A. Right? You can see A has related with only one instance of B, and B is related with only one instance of A. So that we call as one to one relationship. Example is a person has a NIC. The person has only one NIC, and each NIC is belong to only that particular person. Right? There is no NICs that belongs to two persons. Right? From NIC we can't find two people, right? So NIC is belong to that only one person, and the person has only one NIC. So it's a crime to have two NICs, right? Even though some politicians have it, but right? So a person has only one NIC, uh, and the NICs belong to only one particular person, right? So that's one to one relationship. And there is one to many relationship. One to many relationship. That means one instance of entity A can be related to many instances of entity B, but each instance of B is related to only one instance of instance A, only one of instance A. Right? That means A can be related to multiple instances of B, but instance of B is only related to one particular entity in A. It is as a one to many relationship. So what can you think about example? From our hierarchical model, you can think. It's about, let's say, a father and his children. Father can have many children, but a particular children has only one father. Okay? Another example is a customer can place many orders. Customer can place many orders, and the particular order is belong to only one customer. So I can go to the supermarket and purchase some items like some vegetables and some foods. So that's my order. So I can place many orders, but the order is only belong to me. Right? So that's one to many relationship. Then we have many to many relationship. That means many instances of A can be related to many instances of entity B, and the many instances of B can be related to many instances of A. So the instance of A1 can be related to B1 and B2 and B3. Then instance of B1 is related to A2, A1, and A3. Right? The example is a student and let's say here, let's say this is teacher. So a student will have many teachers. Many teachers will teach the student, and the teacher will teach many students. The student will get taught by many teachers, and the teacher will teach many students. Right? So that's the three concepts of ER model: entities, attributes, and relationships. Entity is a real world object to the system that we study. The thing that we keep into the system, it should be have meaningful attributes and should be having some sort of a particular primary attribute, right? Then each entity had attributes. Attributes can be normal attributes, composite attributes, multi-value attributes, and derived attributes. Then we have the cardinality, how one entity is getting related to another entity. So we had one-to-one relationship, like person and the NIC. Then we had one-to-many relationship, father and his children. Then many-to-many relationship, students and teachers. Right? Hope you understood. So with that understanding, consider doing this question. Consider the following statement with respect to ER diagrams. An ER diagram has entities and relationships. An ER diagram has entities and relationships. It's correct, right? It's correct. Then the cardinality of all relations should always be one-to-one. No, right? Can be one-to-one, one-to-many, or many-to-many. Entities may have attributes. Entity should have attributes, right? Entities should have, not may, should have attributes. There could be binary and tertiary relationships. This is correct, right? In a relationship, there can be three entities connected. Three entities connected. Let's say, as an example, a doctor, a patient, and the hospital. Let's say the relationship name is treat. Right? So one doctor is giving his treatments in a one hospital. One doctor is giving treatments in one hospital, and one hospital can have many doctors. Right? One doctor is belong to one hospital, right? And in the hospital there are many doctors. In the hospital there is many doctors who is giving treatments, right? And one doctor can treat many patients, and a patient can get treatments from many doctors. And one hospital can treat many patients, and a patient can get treatments by many hospitals. Right? So in a relationship there can be three entities connected, right? So there could be binary or ternary relationships, right? So theoretically, there can be 4, 5, likewise many entities connected, but it's not like we are not going beyond binary and ternary, right? It's becoming then meaningless, right? So there could be binary and ternary relationships. So the answer is A and D only. Right. Consider the following statement with respect to ER diagrams. Consider the following statements with respect to ER diagram. The relationship in an ER diagram can be implemented as a table in a relational database. The relationship in an ER diagram can be implemented as a table in a relationship. No, right? We are not representing the relationships, but we are representing as tables or entities. Entities, right? So there is a concept as if there is many to many relationship, we are creating another table. So that's we will discuss. So here mainly we represent entities as the uh, table in a relationship. A relationship may have attributes attached to it. It's correct. It's correct. So imagine uh, doctor, 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 and a patient, patient, doctor and a patient, patient, doctor and the patient. So patient make an appointment with the doctor. Doctor has an appointment with the patient. So relation name is appoint. Doctor has an appointment with the doctor has appointment with the first patient. Patient has appointment with the doctor. Right. So doctor will have attributes like ID, name, mobile number. So the doctor will be having appointments with many patients, and the patient can get will be having appointments with many doctors. Right. So in that case, can I put this particular appointment date and time as a doctor's attribute? No, I can't, because he will be having many appointments and dates, right? It's not a unique attribute to the doctor. Then is it a unique attribute to the patient? No, right? Is it belong to the patient? No, because the patient also will be having many appointments and the types. So it is a attribute in, in it is an attribute that belongs to this relationship, right? Date and time. So I can't make uh, uh, specifically put these two into doctor or either to the patient. So these are relationship attributes. So the relationship can have attributes attached to it. It's correct. So a relationship in an ER diagram can be implemented as a table in a relational diagram. In this case, we can consider this as false, but here, if the relationship, there is relationship attributes, so there will be another table. So if we consider that, we can get this as true as well. Okay, so basically we get entities as the tables, and a relationship can have attributes attached to it. Right? Then only two entities can be attached to a relationship. That's also wrong. We can have either binary or ternary relationships. Okay. So the answer is B only. Okay. The third one. Which of the following statements about relational databases is correct? Which of the following statements about relational databases is correct? The value of a composite key of a table can be null. Composite key. What do we mean by composite key? Composite key? Composite key. So imagine if we have a table, let's say the name, contact number, right? In this case, so there can be multiple students with the same name. So this table, we can't consider name as the primary key, and there can be many students with the same class, right? Same class. But let's imagine there is no, like there can be multiple students taken from one class, but there is no student with the same name in the particular class, right? But there can be different students with the same name in different classes, but not in this particular class, right? So in this case, we can't consider name alone as the primary key and can't keep class alone as the primary key. So combiningly both we can consider as the primary key. So that we call as a composite attribute, composite key. So these two attributes combiningly make the primary key. So therefore, a composite key of a table can be null. It cannot be null. Null values are allowed in any column of a table. No, right? If it is the primary key, null values are not allowed. And we can have a constraint like not null. So we will discuss about constraints next week. Then the two or more columns of a table can be combined to create the primary key. Yes, it's true. That we call as the primary key. Then values of a foreign key of a table cannot be updated. No, it can be updated. So if the primary key of the particular related foreign key get updated, it should definitely need to update. Once created, the structure of the table cannot be altered. No, we can alter, we can change, can update. So then, what's the answer for this question as well? Which of the following is correct with respect to relational database? Any subset of alternate keys is called candidate key. So what is the answer to this? What do we mean by candidate key? Candidate key are the keys that we can consider as primary keys. The unique identifiers. From these candidate keys, we select a primary key. Alternative keys means all the other keys that are not the primary key. So any subset of alternate keys is not called as candidate key. Candidate key is something that we can consider as a set of keys that we can consider as primary keys. From that candidate keys, we can find a primary key. Alternative keys means the keys that are not primary key. Okay, so it's wrong. A primary key is selected from alternative keys. No, primary keys will get selected by candidate keys. A foreign key is an alternate key. A foreign key is an alternate key. Is that correct? Foreign key is not an alternate key. Foreign key means what? It's an attribute that is related to another attribute in another primary key of a table, right? Another table. So using primary key and foreign keys are how we create the relationship between the tables. So foreign key is not an alternate key. Always primary key and foreign key combine to create the compound key. Is that correct? It's not correct. compound key or the composite key is the like it's the like two or more attributes combinedly make a unique key that we call the composite key. Then primary key and foreign key establish the relationship between tables. It's correct. So the correct answer is 5. Okay, so that's it for today. So we discussed about basically what is the database, why we need a database, what is a database, structured collection of data. So why we need to store data in a structured manner. So to maintain the data integrity throughout data lifecycle. So thereby we can ensure the accuracy, consistency, reliability of the data. So using a database, we can easily access, manage, and update data. Then the people were using file-based systems, traditional systems, and with the development of computers, people were started thinking, can we use computers to implement database systems? So they came up with different models, different database models. First, we discussed about flat file model. Flat file model. In a flat file, we keep everything in a single table or a single spreadsheet. So they are it's easy to use and there is no much thinking behind it. But it's difficult. We can't define relationship between entities and it become complex and harder to maintain when our data getting large, right? Then we had because of those problems, we had the hierarchical model. We had a tree-like structure where we only can represent one to many relationships, and it was a complex structure, and it was harder to retrieve data from them. And then, therefore, we developed the network model, which had the graph-like structure. In that, we can represent many relationships, but the structure was rigid and it was harder to maintain, right? To do the updates, right? And so complex, very complex database administrators. So the personnel who are working with the database need to have a good. So then in 1970s, a person has introduced the concept of relational today. So there we had tables. The tables are interconnected with relationships using primary keys and the foreign keys, right? Tables and the relationships. That's the main idea behind it. Then there is the object-relational model, which is a development of relational model. So there we implement the object-oriented principles into the database relational model. So then we discuss further about relational model because it is the mostly using database model today. Right. So in relational database model, we had tables. Each table is an entity. Entities had attributes. Attributes were represented as columns, and each row represented a particularly discuss how we can identify an entity. So we discussed that a database is part of the system, IT system. So before designing the database, before developing the database, based on the requirement or the business rules, we need to design it first. We need to design it first. To design the database, we use what? The ER diagram. So every database model consists of three things: entities, relationships, and attributes. So in a ER model, we before designing the ER model, the first thing we need to identify is entities, then attributes, and the relationship. So entity should be important to the system, and it should have meaningful attributes, and it should be uniquely identifiable, and it's something meaningful and valuable to the system being studied. Then attributes can be normal attributes, multi-value attributes, derived attributes, composite attributes. Okay. Then the cardinality or the relationship between entities can be one-to-one, one-to-many, or many-to-many. So next week, with this understanding, let's see how we can design an ER diagram, how we can draw a ER diagram. So I will finish the class for today then. So thank you very much for joining. Let's meet next week. Okay. Thank you very much.